In the grand tapestry of the cosmos, our understanding is woven from threads of curiosity and genius. But did you know that one of the most crucial threads, one that fundamentally changed how we see the universe, was spun by a single man over 4 centuries ago? This is the story of how a brilliant astronomer looked at a revolutionary new invention and saw a way to make it infinitely better, opening a clearer window to the stars than ever before. That man was Johannes Kepler. Living in the late 16th and early 17th centuries, Kepler was a German mathematician and astronomer of profound intellect. He's most famous for his laws of planetary motion, which for the first time described planets moving in elliptical orbits, not perfect circles. This was a radical departure from millennia of thought and laid the groundwork for Isaac Newton's theory of gravity. Kepler was a man caught between two worlds, a devout mystic who sought God's plan in the heavens, and a rigorous scientist who demanded that theory match observation. The year is 1610. A shockwave is spreading across Europe. Galileo Galilei has pointed a new instrument, the telescope, towards the night sky and published his astonishing findings. He saw mountains on the moon, countless stars invisible to the naked eye, and most shockingly, moons orbiting Jupiter. This shattered the ancient belief that everything revolved around the Earth. While many were skeptical, Kepler was electrified. He immediately sought to understand the new device, and as he peered through the eyepiece, the brilliant mathematician in him couldn't help but analyze its flaws. The Galilean telescope, while revolutionary, used a convex objective lens and a concave eyepiece. This produced an upright image, great for a spyglass, but it had a major drawback for astronomy, an incredibly narrow field of view. Finding and tracking objects in the vastness of space was like searching for a needle in a haystack through a keyhole. The images were also prone to distortion, especially at higher magnifications. In his 1611 work, Dioptris, Kepler proposed a radical redesign based on his mastery of optics. He theorized that replacing Galileo's concave eyepiece with a second lens would solve the problem. In the Keplerian design, the first lens gathers light and forms a small, real image inside the tube. The second convex lens then acts as a magnifying glass, allowing the observer to examine this focused image in great detail. The result was a dramatic improvement. The Keplerian telescope offered a much wider field of view and allowed for higher, clearer magnifications. There was just one peculiar trade-off. It flipped the image upside down. For an astronomer, this was a small price to pay. After all, in the vacuum of space, there is no up or down. The immense gain in clarity and ease of use far outweighed the inconvenience of an inverted view. This was a tool built not for Earth, but for the cosmos. Though Kepler described the principle, it was others who first built and popularized his design, which quickly became known as the astronomical telescope. For over a century, it was the dominant design for astronomers, allowing for ever more detailed observations. It became the direct ancestor of the great refracting telescopes of the 18th and 19th centuries, a critical evolutionary step on the long road to the titans of modern astronomy. From the Hubble Space Telescope to the James Webb, which peer back to the dawn of time, the legacy of Kepler's insight endures. He not only gave us the laws that govern the dance of the planets, but also refined the very lens through which we watch that dance. Johannes Kepler didn't just look at the stars, he taught us to look at them, forever changing our place in the universe.